Hello everybody and welcome back to the DCAC channel where we solve, at least for this series, Leetcode questions to kind of prepare for technical interviews and just learn programming, solve questions, learn Python, learn to think, I guess, I hope. Alright, let's jump to another question. Relative ranks. Sounds interesting. Okay, so the question is called 506 relative ranks. Given scores of n athletes, find their relative ranks and the people with the top 3 highest scores, who will be awarded medals: gold medal, silver medal, bronze medal. So basically, given n athletes, find their relative ranks and the people with the top 3 high scores, who will be awarded medals. Example 1. If we have this input, our output should be basically this one has the highest score relatively to the other one, so it gets the gold one, the gold medal. This one has the second highest score, silver medal, third highest score, bronze medal. This one is on the 4th position, this one is on the 5th position. Let's see the explanation. The first 3 athletes got the top 3 highest scores, so they got gold medal, silver medal and bronze medal. For the remaining 2 athletes, you just need to output their relative ranks according to their scores. And there are some additional notes. We know that n is a positive integer and won't exceed 10,000, so we know that we wouldn't get any more than 10,000 athletes, but I'm kind of assuming we could be getting 0 athletes as well, so we have to account for that. And all the scores of athletes are guaranteed to be unique, so we know we wouldn't be having to worry about any duplication of scores. So how do we handle that? I think I will be ordering, so I'll basically get these nums sorted, so I will always know the next person that gets another place on the board. And to achieve this, we are going to be sorting our nums list. After sorting the list, we basically know that our athletes are now ordered, and I think it was in reverse order or in descending order. And now we need to actually map them to the actual result of nums. So how do we do that? Let's just say we copy a array. This would be our output. It will be nums dot copy, and after that we know that, for example, we have all the athletes here that are sorted, and for example, and you can see I actually did some programming beforehand, but I was actually not really focused on the exact definition of this task, so I had to redo it. Anyway, let's imagine our athletes had these positions 6, 1, 2. So we know the athletes with the highest scores will be these ones. And well, actually I want to order them a bit differently, so we know something like this. So we kind of have some diversity. And in this case, we know that this athlete should get the highest score. In our array, they are ordered as such 2 and 1. So we can be going through our array. We could be getting the highest. Basically, let's go over our array for our sorted array. For sorted, for highest rank in nums sorted. Okay, so for each one of those, We could be going like this, or we could be getting the very first 3 of them, and I want to do this beforehand because it will be easier afterwards. Let's get, for example, 4 score in our output, which is a copy array. We know that if this score is equal to nums sorted 0, it should be awarded with output. Score should be equal to gold medal. Else, if our score is equal to the second one in our sorted ranking, this one should be called silver medal. And also, if the score otherwise is in the 3rd position, it will be awarded with bronze medal. And just to kind of see that this works, I wanna just quickly test that. What are we getting? We're just gonna leave those 3, and yeah, we're just gonna test it like this. Unindent. Sorry, this is all indented a bit too much, I guess. Okay. Nope. Well, I guess we'll be getting an index, and we are enumerating so we know exactly where we are, and we can basically save things this way. And if you guys haven't seen the enumerate function before, it's a very useful function. It will basically go over through each of these guys, but it will also count indices, so you can actually save stuff using the indices if you need to, and in this case we definitely need to. And as you can see, there were silver, gold and bronze medal, exactly as we hoped to have them awarded. What else do we need? And I'm actually not going to be doing it this way, or yeah, I'm just gonna hard code it. Maybe we can make it a bit better afterwards. If the length of our nums is 0, we will just return an empty list. And we know this needs to be done because, for example, if we didn't, we just have empty amount of athletes. Here we would be, well, we are actually returning the same thing. So I just forget about it. I think we're actually good even like this. Let's just test it. So if this was an empty list, we should be getting a copy out of an empty list. Here we wouldn't really iterate and we get the output. Okay. So these are the first 3. And after we are done with those first 3, I would actually just wanted to test this. For example, we have an array and I want to basically pop the first element a couple of times, and I want to see what our array, how our array looks like at the end. And as we can see, we actually popped some elements from the array from the very beginning. So we're actually gonna be doing this. Either we're going to be doing this like that, or I'm going through. Let's see. So we know that our elements here have different order, and for each of those we need to find them. So wait, they are ordered now, right? And we know that this one will get the 4th position, but we also need to find it. So what can we do? We can go over to the, for each rank, over our sorted nums, but we will be starting from the 3rd one until the end. And why do we start from the 3rd one? Because from the 4th one, because the first 3 we already took care of. And for each of those we are going for score, again index score in enumerate, and in this case we are using nums, because if we were enumerating over, and you will see why I say that, because now we are looking that if our score, well, our rank, and the rank would be 4 here, right? If our rank 4, I'm sorry, if our actually no, it's actually a score again, but the score also has a rank, and the rank would be accounted as, let's start as a rank that would be set to be 4, and or even 3. We know that we have given 3 ranks already, and we are updating our rank, and we are on the 4th rank. We know that the score here is 2 and the rank is 4, so we need to find the one that has the score of 2 and assign it the rank 4, right? And if we do this in our very first array, then we run into the problem that we are basically creating values that we are looking for afterwards. So it is better to have basically a 3rd array where you can be doing this substitution, right? This one would be 5, we put it here. In this case we don't really see anything wrong. This one of course would be silver, gold and bronze, but there would be definitely overlaps if we were using our initial array. So it is better to have this copied array, which would also be the output array. So we are going over each score in our sorted array, starting from the point after those medals, and we know the rank that has to be assigned, and now we are looking for a score in the original array, and we know if the score, well, score sorted or ranked, score input, or initial. So we know that if the score ranked is equal to the score initial, we can actually substitute this rank, or basically the value that was in our output array, and this would be our output on the position of index, and this would be then our rank, and the rank would be also a string. So looking at this, we are basically assigning ranks, we are counting further ranks, and of course we can actually do a continue in this case, because after we find the rank, we know there are no duplicating ranks. We can actually break this, and after we are done with this basically score out of our ranks, we can go to the next one. And actually, since here we are, since we are actually done with searching in our initial array, we can actually go to the next ranked integer. We can actually break this loop and just go over to the next one. And quickly, I really just want to test it out, see if that works the way it was intended. And let's say, for example, we have 1 and 2. Let's have them ordered like this. Hopefully we didn't write anything in the output array, we didn't mess up the values, but I don't think we did. Yeah, so as you can see, this is the first place, gold medal, the second place, silver medal, third place is the bronze medal, and then of course this one is the next one to go, the fourth place and the fifth place. And how are they ranked, the fourth and the fifth place? Well, we know that we actually already assigned those three places. The very first 3 places got assigned already. For this one, which is here, this is score ranked. We were taking it from our sorted array. We know it's a 2, so the ranked score is 2. The rank itself was basically 4 because it's the 4th ranked position. And here we are looking for where in our nums array can we find the 2 that we are looking for to put our score rank basically 4. And we are seeing that it is found on the index position of 1, so we can use this index position of 1 and update our output array. And basically this is it. Once we find this element, we don't have to go over to the next one, and we don't really need to search over through the whole array. So you actually break the algorithm, basically this loop, and we go over to the next element. The next element is 1. It gets the rank 5 because this got updated twice basically now, and we are looking for a 5. We are looking for a 1 in this array. We see it's on the index 0, so we can use the 0 index and put the rank 5 there. Yeah, so this is basically our algorithm. It's a bit it's not the best, I think. I wouldn't really see any way to do it in one line, but I think at least we will get a version that is working. And it was actually not that easy. I really think I thought it was a way easier algorithm at the beginning, and maybe I'm still overlooking something, but yeah, it was still an interesting algorithm. And you can definitely see, you can definitely do solutions, for example, just having a rank, like a fixed rank, and just going over the whole list of contestants and just finding the biggest one and always assigning the next rank and the next rank. But I don't think, well, actually, no, I don't think this would have been a better solution. Sorting definitely helped, and I think you can actually do more magic with the sorted array as is. I just don't have it in my head right now, and I should definitely start making those videos at the beginning of the day and not at the very end. But anyway, that's for me. I hope you guys learned something, and I hope it was educational. Definitely try this algorithm yourself. I think it's not as easy as it looks like, probably like just watching. Once you start thinking about it, you see that it's tricky to get a hold of all the indexing, get a hold of the values, positions, and kind of like their relevance in the whole idea, and to actually not mess up swapping values that are essentially needed for later and stuff like that. So yeah, it was a good time coding this algorithm. I hope you found that useful. If you are new to the channel, can maybe consider subscribing. It will definitely help me a lot. I just hit my 10 subscriber goal, and this sounds like amazing to me already, but I'm already looking towards the next goal, which would be 20 subscribers. So if you could help me with that, that would be awesome. But also thanks to everybody that subscribed, although most of you are kind of like friends and family, but it doesn't really matter. Thanks to everybody, and yeah, see you next time.